It's what's going on. Wayne says, I hope you guys are ready to crack down on these test corrections. Here we go. 3.1 to 3.4. Problem number 1, so we want to find the absolute extrema of our function cosine of pi x on particularly this closed interval. Okay. The absolute extrema means that we should find two answers. Okay. We should find a min and a max. Okay, so that's what we're going to be finding. We're going to be finding two answers on this interval. What's the highest and what's the lowest point on our graph right here? Okay. So let's go ahead, and the way that we do this is we first have to find the critical numbers, and that's a two-step process. Find the derivative of our function, set our derivative equal to 0, and those x values are what we call a critical number. So let's do that. So f prime of x, derivative of this is a sine of pi x, but then we take the derivative of inside of the chain rule, multiply that by pi. Okay, so that's the derivative. Now let's go ahead and find the critical numbers by setting the prime equal to 0 and solving. All right, so pi sine of pi x equals 0. I'm going to go ahead and divide both sides by by pi. So that's going to be a sine of pi x equals 0. And let's think here, what are all the values if I take the sine of something that's going to give us 0? Well, look, if you look at the unit circle right here, what's it? This is 1, 0. This right here is 0, negative 1. Negative 1, 0. And 0, negative 1. Well, the only values that I plug in right here is just going to be 0 and pi. Right here? So 0 and pi are the only ones that will give me a value of 0 here. Okay, but the thing is that if I plug in, okay, if I plug in 0 right here, okay, pi times 0 is just 0. So sine of 0 is 0. So that's fine. But if you try to plug in pi right here, well, pi times pi is pi squared. Sine of pi squared is not 0. So I'm actually not going to use this one, okay, because it's pi times x. So I'm only going to use 0 then. So there's only one value that will give me 0, which is just 0 itself. Okay, so we have our critical number, cool beans. Lastly, what we do is that we're going to plug in 0 and we're going to plug in 5, 6. And well, since we already have 0, so we're only going to do it once, but we're going to plug in 0 and 5, 6. And whatever their y value is, that's how we're going to determine what the absolute extrema is. Whatever the biggest number is, that's our max. Whatever the lowest number is, that's our minimum. All right, so let's just first plug in 5 over 6. So I'm just going to go ahead and we plug that into our original function, by the way. Okay, so f of 5 over 6 is just basically cosine of 5 pi over 6, which is one of our very, very nice values on our unit circle. You can go and look that up, and that's just going to give us a negative root 3 over 2. Okay, and lastly, f of 0. So that's cosine of pi times 0. Well, pi times 0 is just 1. So hopefully the answer is kind of obvious here. 1 is bigger than negative root 3 over 2. So this right here is what we would call our maximum. And we will call this dude right here our minimum. All right. And that concludes that right there. Moving along. Question number 2, determine the open interval in which this graph right here is concaving upward or downward. All right. So we're going to try to figure this guy out here. And that's when we have to use the second derivative test, right? So we do the first derivative, and then we do the second derivative, find those points or that point from the second derivative, and then we test the interval from the left of it and to the right of it, and that's how we're going to figure out what's going to be concave up or down. Let's first take y prime. Okay, so y prime of this guy, negative 24x squared. Prime of that is 16x, and prime that is 2. Cool bean. Now let's go ahead and take our double prime. That's going to give us a negative 48 x, and then prime of 16x is just plus 16. Okay, let's go ahead and find the zeros right here. So I'm going to set this equal to 0. So I'm going to kick this negative 16 over. Okay, and then I'm going to divide by 48, a negative 48, and it's going to go into it 1/3 time, so 1/3. All right, so we only have one number to test here. Okay, so if you kind of think about this in intervals now, if you kind of negative 1/3 is right here, we want to kind of find out what's happening to the left of 1/3, or negative 1/3, and what's happening to the right. So we can pick any number that's to the left of negative 1/3, and it doesn't matter. And I'm going to pick one that's quite simple, which is just going to be 0. I'm sorry, positive 1/3 times. I'm going to pick 0 then. Okay, so what happens at f double prime of 0? What's the sign? And I don't care what the answer is, just what's the sign? Well, if we come back over here, if I plug in a 0, well, my answer is going to be positive. So since our answer was positive, then that means we have a concave up. So that means from negative infinity to 1/3, that's going to be a concave up. Okay, and let's find out what happens over here. Any number that's to the right of 1/3. So I think I'm just going to pick 1. And what sign is that? Well, if I plug in 1 right here, negative 48 plus 16, well, that's going to give us a negative value. And by the second derivative test, if our second derivative is negative, then that means we have a concave down. So from 1/3 to infinity, I have a concave down. Okay, so those are our two answers right here, concave up and concave down. Going down like it's cool. All right, let's lastly do this problem on this part of our video. Find the relative extrema of the function. And here it is right here. And if we need to use the second derivative test, okay, the relative extrema is now just referring to either that max or min. So let's just take our derivative, and whatever the critical point is, that's pretty much going to be our max or min. All right, so f prime of x, so take the prime of this guy, negative 8x, take the prime of that is 32. And let's go ahead and, what are the zeros? So I'm going to kick this 32 over here. I'm going to divide by negative 8, and so we get 4. So this 4, this critical number, means that it's either going to be a max or a min, and we kind of know that, right? I mean, if we look at the graph right here, we know this is a parabola that's going down. So I know that this 4 represents that vertex. So it's going to be 4, and so basically we just need to find the y value right here. Well, it's not 0 though. Okay, so we've got to find the y value, and we know how to find the y value if we have the x. We just plug in 4 back into our function right there. So if we just plug in a 4 right here, so what's f of 4? Well, it's going to be negative 4 times 4 squared plus 32 times 4 minus 62, and that's just going to give us 2 right there. Bam, and so that's what that represents. So our relative extrema is going to be at the point 4, 2.